This will, though. All right, the test topics. What's one test topic that we're going to have? Euler's method, yep. And Euler's method looks like this. You have some derivative equation, dy dx equal to f of x n yn. So it's some kind of an equation. And then the formula is just going to be y1 equals y0 plus h times f of x0, y0. Then the next one will be y2 equals y1 plus h times f of x1, comma, y1. You just stick those in, and you just keep going. That's Euler's method. What else is going to be on there? Yeah? Yeah, that's the integrated factor. That's going to come in threes here. We have an integrated factor. Integrated factor, homogeneous substitution. See you guys. Thanks again for coming in this morning. Substitution.
Thank you.
Good luck. Let it snow. Substitution and separation of variables. These are all substitution of variables. That's what it is. Variables. Now, this one is probably the easiest. If you had like dy dx equal to xy, you could put the x's together, x dx, and you could put the y's together, y dy. And then you'd integrate that separation of variables. You'll see one of those tomorrow. Okay? Then you might have one where you have to substitute that u equal to y over x, or u equal to, I'm going to write O-T-H-E-R, other. They could come up with tons of different ways. Yes. So, yep, any of these that aren't on your packet, you need to memorize. Yeah, and slope fields are coming up. Yeah. It's a real easy slope field. I wouldn't even study it because you got the other things to practice. Yep.
So when is it sometimes on homogeneous substitution?
Yeah.
They'll say like substitute x equals y.
Yeah.
And so.
That's just cross multiplying u and x equal to y.
But you just do it y over x.
Yeah.
Still?
U is still y over x.
Do you know why they do that?
I think they do that because it's easier to print ux equal to y. It's laziness. I think. And then the purpose of homogeneous is when you make these substitutions and you get rid of the y's and with replacing the into u's, you can separate them, and that separability of variables and antiderivatives allows you to take the antiderivative. So what you're doing is you're just turning this into one of these. And the same thing here. You're turning this into one of these. Yeah.
Is it going to tell us which thing to do?
So if they, in the problem, say, let u equal to y over x, then it's a giveaway. It's homogeneous. I will probably give you a hint. Okay? But normally, if you see things like x squared and y squared over xy, that's probably going to be one of these. All right, and then the last one, integrated factor, there's three formulas you need to know for this. And I'm going to write them down here. The first formula is the form it has to take, dy dx plus p of x times y equals q of x. What that means is you have dy dx plus something y plus something not y. And you've got to get it in this form so you can pick off what p of x and q of x is, because I, integrated factor, is going to be equal to e to the integral of p of x dx. And then here's your y iota y times I of x equal to, all of you guys have a very high IQ. And all of these go together. Now, have I shown you where these two come from yet? Oh, I'm going to do that next. But those are what you need to study for, and there will be a slope field on here, which you guys didn't have any trouble with, I don't think. Just remember what the slope field means. Each point has these slopes. So what you would do is you would take a point and just kind of follow it to make the curve. And this way you can say that the derivative equation can be turned into a y equation. So you're finding y. And all of these, you're finding y. Y equation, y function, y value. And that's the test tomorrow.